In electronics design, how do we control a DC motor? For example, controlling the speed and direction of the motor. The conventional method is to use MOSFETs. When we apply a high voltage, the MOSFET conducts, and the motor starts running. By applying PWM with different duty cycles, we can control the speed. And when we apply a low voltage, the motor stops. For controlling the motor's direction, we need four MOSFETs, forming an H-bridge driver circuit. If we activate Q1 and Q4 MOSFETs, the motor runs forward. If Q2 and Q3 are activated, the motor runs in reverse. For controlling 6 DC motors, 24 MOSFETs are needed, making the circuit design more complex. To address this, smart engineers invented a driver chip, integrating the MOSFETs into a single chip, simplifying hardware design. Let's take the NSD8312 driver chip from the Chinese company Naxon Wei. As an example, this chip is powerful and easy to control. It integrates 12 half-bridge drivers, and external devices control these through SPI communication. Here is the driver board for the NSD8312 chip, with the 12 half-bridge outputs connected to a green connector. To make debugging easier, it comes with a control board. Additionally, the manufacturer provides software to control the chip via computer. By default, these 12 half bridges do not output power. We send the command 0802, and the first half bridge will output power. We connect one motor wire to out 1 and the other to ground, and the motor will rotate. The reason for sending 0802 is defined by the chip. 2 bytes are sent for each command. The first byte is the register address, and the second byte is the status or command. For example, to control the first half bridge, we use the HB Control 1 register, which has an address of 08. Therefore, the first byte is 08. To control the output, we write 1 to the HB Shen bit and 0 to the others, which in hexadecimal is 02. Thus, sending 0802 will make the motor spin. If we connect the 2 motor terminals to 2 half-bridge outputs, we create an H-bridge. By setting out 1 to high and out 5 to low, the motor turns forward. Setting out 5 to high and out 1 to low makes it reverse. The chip also includes a PWM generator. If we enable PWM for the 5th half bridge and adjust the duty cycle to 50%, it will output a half wave, making the motor speed about half of the original. Duty cycle can be adjusted using a calculator, and a 10% duty cycle will result in slow speed. Besides basic control, the driver chip integrates diagnostic features like overvoltage, undervoltage, overcurrent, short circuit, over-temperature shutdown, and open-loop diagnostics. For instance, if the motor is disconnected, the open-loop diagnostic will report this state, and no voltage will be output. Finally, the NSD8312 is an automotive-grade chip, which can operate in more extreme environments compared to consumer-grade chips. Its main applications include driving DC motors in vehicles, controlling rear-view mirror adjustments, relay control, and simple LED ambient light adjustments. That's a look at the features of the motor driver chip. Hope this helps with your understanding.